Hey guys, welcome to this tutorial on object-oriented programming in Python. This video is going to assume you know the basic definitions of object-oriented principles from the lectures, and it's going to be focusing on how to implement them in Python. The first thing we're going to have a look at is how to write classes and objects in Python. As a quick recap, in object-oriented programming, a class is kind of like a blueprint or a template for creating objects. Also recall that classes have attributes, properties, and methods. The attributes are things which the class has, and methods are functions which we can call on the objects. Let's have a look at this class for a person. The keyword for creating a class in Python is class, followed by the name of the class. In this case, it's called person. And generally, we start the names of our classes with a capital letter. Everything indented under this line belongs to the class. So as you can see, we have three methods that belong to this class. We have init, walk, and calculate age. Okay, first let's take a look at init. The function called init with the double underscores is what we call the constructor. So a constructor in object-oriented programming is a special method of a class that's called when you create an instance of this class. So as the name suggests, it initializes an object of that type. You can call a constructor by using the name of the class followed by brackets. So say I want to create an object of type person called person1, and I'll assign it to an instance of person by calling the constructor. So I'll type person followed by round brackets. Okay, so as you can see, the init function takes three parameters. We can ignore self for now. The other two are what we pass into the constructor when we call it. Usually a constructor accepts the initial values for the attributes, but you can make it take in anything you like. So here it takes in a first name and a last name. So let's pass these in. And let's make a second instance called person2. Then you can see in the body of the constructor, we're setting the values for our class attributes. So attributes in a class are denoted by self dot and then the name of an attribute. So we have three in this case. We have first name, last name, and date of birth. First name and last name are set to the value of the parameters which we've passed in. So the first name attribute equals whatever we passed in for first name, and last name attribute equals whatever we passed in for last name. And then date of birth, we're just setting to datetime.now, which is a library that gives us the current date. These attributes can be accessed anywhere in the class. So as you can see in this walk method, we're accessing self.firstname in this print statement. And then you can see in calculate age, we're accessing self.date of birth in this calculation. So there's our class and attributes and methods in the class. Now having a look at person1 down at the bottom, this is an instance of the class. And our methods in the class, so walk and calculate age, can't be called by themselves. They have to be called on an instance of the object. So for example, if I want to invoke the walk method, I can do person1.walk and pass in whatever parameters it takes. So it takes in self and it also takes in distance. So again, we'll ignore self for now, but I'll pass in 50 for a distance. Say I want to call calculate age for person2, I can just call this in the same way. So I'll make a variable called age and call person2 dot and then the name of the function. Okay, so the next thing we're going to address is self. So you'll notice that we have self before all of the attribute names and passed in as the first parameter for each of the functions in the class. Self is essentially a reference to the current instance of the class. So outside of the class, we refer to instances by whatever their names are, so person1 or person2. While we're inside the class, we refer to the current instance as self. So when I'm setting self.firstname, that's setting the value for the attribute first name for the current instance. As you can see, self is the first parameter of all the methods. So init, walk, and calculate age all take in self. Self is implicitly passed in when you call a function on an instance. So when I do person1.walk, this is passing in person1 as the value for self. This is essentially the same as doing person.walk to refer to the walk method in the person class and passing in person1 as the instance. Similarly, to access attributes, while we're inside the class, we say self.firstname, but if I'm outside the class, I can do something like print person1 dot first name to access the attribute for a specific instance. Okay guys, next we're going to have a look at encapsulation and how to make our Python object-oriented code encapsulated. So let's start with the definition of encapsulation. So encapsulation is the act of hiding the internal representation or the state of an object from the outside. So this means that class attributes should be kept private and only accessible or modifiable by public methods. So why do we want encapsulation? So encapsulation allows us to preserve the state of the object and impose restrictions on how the data in a class is allowed to be modified. It's also useful to keep attributes private sometimes so that they can't be observed from the outside in case they contain sensitive information. A good example of a case where encapsulation is useful is in a credit card system. So say I have a class for a credit card, it's important that the balance attribute is kept private and is only modifiable by public methods such as withdrawing or depositing. Let's look at this same object-oriented code from before. So in this code currently, the attributes first name, last name, and date of birth are public and can be accessed from outside the class, which breaks encapsulation. So if you look at this line down here where I'm printing person1.firstname, this is breaking encapsulation since it's outside of the main body of the class code. Let's change this code so that the attributes are private. In Python, we don't actually have private attributes. However, we can use an underscore at the beginning of an attribute's name to indicate that it's private. So I could do self._firstname, self._lastname, self._date of birth, and change those everywhere in the code. So having this underscore at the beginning of the name doesn't actually prevent it from being accessed outside the class, but it's there to indicate to other people looking at the code that the attribute is intended to be private, so that it shouldn't be accessed from outside the class. If there's attributes we want to expose, so we want them to be accessible from the outside, we use getters and setters. A getter is a method inside a class which returns the value of a private attribute. So as the name suggests, we want to get the value of an attribute. And similarly, a setter is a method which takes in a new value for the attribute and it modifies the value of that private attribute. Let's do an example of getters and setters. So say we do want to access the first name from outside of the class. I'll make a getter for the first name, which is a method called getFirstName. And this method just returns the value of the private attribute. So now in this print statement down the bottom, rather than printing person1.firstname directly, we'll print person1.getFirstname, which no longer breaks encapsulation. Say we want to also change the first name from outside the class, let's make a setter. So I'll call it setFirstName. And as a parameter for this setter, I'll take in the new value, so new name. And inside this function, I'm just going to change the value of that attribute. Down the bottom, I can call this setter by doing person1.setFirstName and pass in a new value for the name. So say I want to change John's name to John without a H. These getters and setters don't need to be called getFirstName and setFirstName, but the standard convention is to have get followed by the name of the attribute. Okay, let's take a look at this new example of a credit card system class. So as I mentioned briefly before, a credit card system is a really good place where encapsulation is important because we're holding sensitive data and we don't want to be able to change the balance directly. We should only be able to change it with public methods. So here I've created a class for a credit card system, which accepts an initial balance and the name of the account holder. And then I have some methods for withdrawing, checking the balance, and depositing. And as you can see here, I've put the getter and setter for the account holder. And then finally at the end, you can see that I've just made an instance of this class called myCard. Say we want to make a withdraw method that allows a user to give an amount and then it'll withdraw that amount from the account. We don't want someone to be able to withdraw an amount that's greater than their current balance. And we also might want to put a restriction on how much someone is allowed to withdraw per day. This is a case where encapsulation is really useful as we can put restrictions on the ways that people can change the value of the attributes. So in the withdraw method, we could put an if statement checking the amount that they're attempting to withdraw and making sure that it's greater than their current balance. So I'll say if amount is greater than self.balance. I'll print an error saying that they're not allowed to withdraw. And then otherwise, I'll deduct the amount from the current balance. Say we also want to add a $2,000 withdrawal limit per day. I'll add an extra condition to the if statement checking if amount is too large. Great, now let's implement the check balance function. So this can just be a getter for the balance. since from outside the class we can't access this attribute directly. So let's simply return the current balance. Finally, let's implement deposit, where a user can specify an amount and this amount is added to the current balance. So we might want to add a restriction, say that you can't deposit more than $10,000 at once. We can add an if statement checking if amount is greater than $10,000. We'll print an error. Otherwise, we'll add this amount to the current balance. Great, so now we've implemented our credit card system fully encapsulated. So what we've just looked at is getters and setters, which are a way of enforcing encapsulation. Python has another concept called Python properties that are a way that we can have encapsulation using some built-in syntax. So Python properties allow us to specify the getters and setters for an attribute in a way that encapsulation is enforced. Take a look at this quick example. So I created a class called test, and I have one attribute called myAttribute, which has the underscore, meaning that it's private. Inside the body of this class, I've defined two functions, which are the getter and the setter using the Python properties syntax. For the getter, I've defined a function and given it a name, which is the name that we're giving the property. So I've called it myAttribute. And just like the getters we saw before, it's just returning the value of the private attribute. So returning self.myAttribute with the underscore. You'll notice that I've added this at property line above, which is what we call the property decorator, and which is a way of specifying that myAttribute is a Python property. The function underneath is what we call the setter. So it's specified by giving the name of the property, myAttribute.setter, and then this behaves just like a setter we saw earlier. So it takes in the new value and you can set the new value inside the body of the function. These differ from standard getters and setters. So when we had getters and setters, I would be doing x.getMyAttribute or x.setMyAttribute with a new value. While using Python properties, we're able to treat this property like an attribute rather than a function. So if you have a look here, I've created x as an instance of test, and to use the getter, I simply do x.myAttribute. To use the setter, I do x.myAttribute and equals with a value. So even though this looks like I'm using an attribute, it's actually using these Python properties. I can put in some print statements to confirm this. So let's put a print statement in myAttribute saying calling getter and a print statement in the setter as well. So if we run this code, what we expect will happen is that it will print calling getter with the initial value of myAttribute, which is 5. Then it will print calling setter. And then finally, it'll print calling getter again with the new value of the attribute, which is 10. So let's run this code to test this out. So as you can see, it calls the getter and prints out the value. It calls the setter and it calls the getter again with the new value. Alright guys, so as a recap, we've had a look at the basics of object-oriented in Python, so how to write a class, attributes, and methods. And we've had a look at encapsulation in Python, so how to make our attributes private and how to use getters and setters to get or change the values of our private attributes. Thanks for listening guys, hope you learned something.